Here is the Spiker Box overview final video. A Spiker Box is a bioamplifier which allows one to see and hear action potentials of neurons of invertebrates. Here is the basic assembly of the Spiker Box. For a more detailed version, please visit a prior video. It would be wise to organize the pieces before beginning. This will help you keep track and also will help prevent losing any pieces. You will need to solder many pieces onto the PCB board. Here's an image of a PCB board. Be careful while handling this board as it is very fragile. This is how the Spiker Box will look like just prior to finishing installation. As you see, there are many capacitors and resistors installed, along with the screws and washer. This is the image of a final Spiker Box. It is now ready for experimentation. The Spiker Box is part of the STEM Education Coalition, which was initiated to develop science and research skills in students. STEM stands for Science, Technology, Engineering, and Mathematics. The S in STEM stands for Science. The science portion of the Spiker Box deals with understanding action potentials and the nervous system. The T in STEM stands for Technology. We use technology multiple times in the Spiker Box project, as you see here in this image. We had the Spiker Box connected to the iPad to see action potentials. We also used computers to watch videos for the Spiker Box. The E in STEM stands for Engineering. This term encompasses all of the building that goes on with the Spiker Box. M in STEM stands for Mathematics. Analyzing spikes and analyzing any kind of data in the Spiker Box project is part of the mathematics section. There are 8 crucial steps in the engineering design cycle, which start from identifying the problem and end with redesigning the product. Referring to the Spiker Box, in our class we only did steps 5, 6, and 7. Backyard Brains took care of steps 1 through 4 and perhaps step 8 as well. This dedicated team from Backyard Brains completed steps 1 through 5 and step 8 of the engineering design process. They identified a problem, which was that there was no way to cost-effectively see and hear action potentials of neurons in invertebrates. They created the Spiker Box and have now recently redesigned it to make it even better in order to test and evaluate results. Step 5 of the engineering design cycle primarily was done by Backyard Brains. However, we did recreate and build a Spiker Box. We completed step 6 of the engineering design cycle by testing and evaluating the Spiker Box. We did this by hooking up an invertebrate to the Spiker Box and seeing if action potentials could be seen and heard. The next step is to communicate with your peers. Not only did we do this in class within ourselves, but also posted informational videos onto YouTube. The nervous system consists of both the peripheral and central parts. Each have their own duties. Nervous system impulses are transmitted by cells called neurons. These are the focus of the Spiker Box project. A stimulus enters a neuron through the dendrites. A stimulus must reach threshold in order to cause an impulse. An impulse begins when a neuron is stimulated by another neuron or by the environment. If the stimulus reaches threshold, an action potential will begin and the impulse will travel through the cell body and down towards the axon. At resting potential, the charge of the neuron is negative 70 millivolts. There is a slight negative charge inside the cell due to the imbalance of the number of potassium to sodium ions. As you see in the image in the top right, there are sodium-potassium pumps, which help the movement of ion. Within the cell, at resting potential, there is a greater amount of potassium within the cell. At the leading edge of an impulse, gated sodium channels open, allowing positively charged sodium ions to flow into the cell. When an impulse begins and an action potential occurs, there's a greater amount of sodium ions within the cell compared to outside the cell. The rapid reversal of charge within the cell causes an action potential and a positive charge within the cell and a negative outside. Depending on the strength of the action potential, an impulse can travel to the synaptic cleft and move on to another neuron through the dendrites. The point at which a neuron transfers an impulse to another cell is called a synapse. The axon terminal at a synapse contains tiny vesicles filled with neurotransmitters, which are chemicals that transmit an impulse across the synapse to another cell. After understanding all the components of the spiker box and the neurosystem, we are now ready to experiment. In this project, we will show you how neurons make use of oxygen. The first step will be to freeze a cockroach until it is paralyzed, and then remove the leg and put petroleum jelly on the wound. While the cockroaches are freezing, go ahead and set up the iPad and connect it to the spiker box. It would be great to be in a quiet location so there's no background noise. Also, it would be great to put the spiker boxes in a metal net as you see here in order to prevent any possible background noise. For at least 30 minutes, leave a cockroach leg on the spiker box and examine the spikes. It would be easier if you had multiple spiker boxes so you could put multiple legs on them at once. You should notice that the spikes are long because there are many impulses in the invertebrate. After at least 30 minutes, put petroleum jelly on the leg and then hook it back up to the spiker box. After a few minutes, you should see that the spikes begin to slow down, and after 20 minutes or so, they should stop. Depending on many factors, ranging from about 20 to 40 minutes, you should see that the spikes begin to significantly slow down to at least this level or flatline. When the spikes stop your stopwatch, and then remove the petroleum jelly so you can see when the spikes begin once again. Due to our time and resource restrictions, we were only able to test 3 cockroach legs. Ideally, you would like to have a large sample size with an equal amount of tests and controls, as well as a longer amount of control time. Our average time for the roach to stop having spikes was 17 minutes and 43 seconds. This data proved that petroleum jelly stops action potentials and that oxygen is critical to life. Enjoy your spiker box. For more information and more experiments, visit backyardbrains.com.